All right, I know you couldn't wait for part 4 is all about fractions. I can hear you cheering. Just remember, some things like if you have the same denominators and you are adding or subtracting, I could even add these, right? Is the denominator stays the same, and then you just do what it says here, 6 minus 2, 4, or 6 plus 2, 8, and then you always look to see if you can reduce. They only get crazy when you don't have common denominators, right? And so let's look at something like that. Let's say we get real crazy and we have 7 over 8 plus 1 over 16, and all of that is squared, minus 1 over 4 plus 1 over 16. Well, remember, please excuse my dear Aunt Sally, we want to do what's in parentheses first, but I kind of would eyeball and make sure you're going to get all of the same denominators. You don't have to do that this step, because you could do it after you do this step and then that step. But I can see that it looks like all of these, the least common denominator is going to be 16. Why? Because 8 will go into 16 and 4 will go into 16. So anything that does not have a 16, I'm going to multiply it by 1, hence 2 over 2 and 4 over 4. So this piece becomes 14 over 16 plus 1 over 16. Don't lose that squared. This piece becomes 4 over 16 plus 1 over 16. Once again, you do what's in parentheses first, so I'm going to add, I know that's going to be over 16, 14 plus 1, 15 squared, and then I'm going to add here 5 over 16. So I need to square, and I'll leave that up to you, 15 times 15. If you don't get this, let me know. But 15 times 15 is 225. And then 16 times 16 is 256. Uh-oh. Now we don't have a common denominator. So guess what? We have to find a least common denominator of this. Well, what I would do is the prime factorization. So I have 16, I have 4 times 4. Let's leave that, let's just factor it. Let's not do prime factorization. I'm gonna look at this and I'm gonna guess, okay? I don't know if I'm if I'm correct, but I'm gonna guess, does 4 go into this? So this would be 4 times 6, 24. And you might say, well, but how would I have known that? That's how math books work. You just figure that probably one of these are going to be one of these factors. Okay? And so then of course I have a 4 in common, but I need to think about my 64, which is 8 times 8, but I can look at this and say, something else that I might think about is, leave that 4 there, does 4 go into this again? And it actually does. Okay, so 4 goes into 16. So I can see for my denominators, it looks like I have 4s in common, but not that 16. So all I need to do is multiply this times 16, and guess what that is? 256. So if you recognize that this was my least common denominator, because I can multiply, oops, meant to get another color. I can multiply 16 times 4, and again, a lot of this is just doing, I said by 16. A lot of this is just, the more math you do, believe it or not, you start to kind of get this kind of stuff. And so 16 times 16. Another hint that you might have seen that was back here when you squared this, right? And so now I'm going to get 225 over 256. I know that bottom is 256, and I know 5 times 16 is 80. and then 225 minus 80 is 145, and then over 256, which would be your final answer. Let me see anything else that I can do while we're in here. Yeah, let's multiply. So when you want to multiply fractions, say you have 5 over 7 times 8 over 6. So the rule is you just multiply straight across, right? So in other words, 5 times 8 is 40, and 7 times 6 is 42. But what I like to do is if I have 5 times 7ths, I know there's nothing that I can reduce out of there. But think of 8. Isn't 8 2 times 4? And isn't 6 2 times 3? I mean, I'm hoping you're getting the whole why do we reduce stuff, because when we reduce like this, it helps me now that, see, my final answer is 20 over 21. Well, I could have done the same thing up here, that I could have said that, well, 40 in this case is the same thing as 2 times 20. And then I could have done the bottom, the 42 is the same thing as 2 times 21, and I would have canceled. It's just doing it this way down here makes it where you're not having to multiply such big values.